question 18. Calculate the length of BE. That's this length here. Now, you've got the intersecting chord theorem meeting in the circle, and that's really very simple. All it says is that these two multiplied together equal these two multiplied together. So x times 2.4 is equal to 3.6 times 2.8. So x is equal to 3.6 times 2.8 over 2.4, and I think the answer was 4.2. I can't remember, but yeah, pretty easy to work out. The tricky one is this. Angle AED is here. The angle from A to E to D. Now, you don't know any other angles, and this isn't a circle theorem question, although it might look like it. The reason being that in any circle theorem question, unless it's very clear that you've got a diameter, you would expect to see some angles marked. But you don't. What we need here is to look at the triangle. The triangle AED, I'll write it down here, looks like this. We've got 3.6, we've got 2.4, and we've got 4.9. And the angle we're trying to work out is here. Now, there's a way of labeling triangles for the cosine rule, which you'll see in the formula book. Basically, if we give the sides little letters, A, B, and C, the angles that are paired with those sides are the ones opposite them. So if that's side A, then angle A with a capital letter is here. Angle B is opposite side B, and angle C is opposite side C. And the cosine rule relates the lengths of the three sides to one of the angles, depending on which position you're looking at. The cosine rule starts like this. Pythagoras' theorem, but with one correction that makes it apply to all triangles and not just right angle triangles. So this is effectively Pythagoras' theorem is effectively one small part of this big picture. Pythagoras' theorem only applies to right angle triangles. This is the method for finding the length of a side for any triangle. So the length of the sides doesn't have to be the hypotenuse, it can be any line, because obviously you don't have hypotenuses in non-right angle triangles, is equal to the sum of the squares of the other two sides minus 2 times the other two sides times the cos of A. Now, there's only one angle named in this formula, big A, and it's the angle opposite the side you're trying to work out. So what this formula says is, if you know the three sides and you want to work out a particular angle, you can apply the formula in this way. You pick the side opposite and you say that side opposite is equal to these two angles squared and added, Pythagoras, minus 2 times these two sides squared times the cos of A. So we know what A, B, and C are, and we know what BC is, and we're going to work out A. So we say 4.9 squared equals 3.6 squared plus 2.4 squared minus 2 times 3.6 times 2.4 times the cos of A. We work out these values. 4.9 squared, sorry, is 24.01. 3.6 squared is 1. Oh dear, too slow today. 12.96, I think, and 2.4 squared is 5.76. Minus 2 times these two. Oh boy, okay. I should have got the calculator out. I'm going to cheat and get a calculator. It's too late to be working this out by hand. Sorry for the slowness. 17.28 times cos A. So we're going to work out what cos A is. Obviously we can subtract these two from both sides. If I do 12.96, let's put the calculator on here. If I do 12 and 5.76, I get that. And if I do 24.01 minus 18.72, I get that. So 5.29 is equal to minus 17.2. I've got to be very careful with the negatives here. Cos A. And if I then divide both sides by minus 17.28, I get minus 0.306 equals cos A, which means that A is the inverse cos, and I'm in radians, so I'm going to have to get back into normal functions. You should be aware of this. If it says rad or r up here, that means you're not in degrees mode, which is bad. So you need to be in degrees mode. I'm going to switch that back into degrees mode. It's gone to grad, and it's gone back to degrees. And so now I'm going to type in that minus 0.306 number, and I'm going to do the inverse cos. You have to type in a certain way. I'm going to do inverse cos of minus 0.306. I'm going to put that in brackets just to be sure. You should do it to at least three decimal places. That might not be accurate. I probably should have done it to 4. And if we do that, we get 107.8 degrees. Now, this is why I should have been a little more accurate. It says give the correct answer to 3 significant figures. Now, if I gave this answer, if I simplified my calculation here, 3 significant figures, I would have said this was 107.8, and I would have given my answer to 3 significant figures to be 108 degrees. Now, I have to be careful. This happens a lot in trigonometry. If you simplify your answers too early here, you can run into problems. Now, I'm going to do the answer properly now, and just make sure that it agrees. It might agree, but it might not, and you should be very careful. In any question involving trigonometry, don't round until the final answer. These are all exact values, so these are fine. But this answer I rounded, and I shouldn't have done that. 5.29 divided by minus 17.28 is minus 0.3061. And so really, instead of this line, I should have said minus 0.306. Now I want the answer to 3 significant figures. I should use this to at least 5 to make sure of accuracy. So I'm going to go for 6 just to be really sure. Now, if I inverse cos this, I still get 107.8, so I'm lucky this time. But there are definite examples where you won't get the same answer if you're not accurate enough, so please do be careful. 107.8 degrees, so to 3 significant figures it's 108, and that's the final answer.